Yar, ahoy there, matey. It be time to go in search of treasure. But we're all physics pirates here, so we're going to end up looking for pirate treasure kind of the way that physics pirates do. And but welcome, we're going to walk through part of this together. And the big thing about physics pirates is they like to measure things in the metric system, but they also like to look for treasure and follow directions. So even though we have a treasure, pirate physics pirates end up making physics pirate maps. All that. So that's what we're going to do. And so there's different steps to this project, and you're going to complete all of them with making your own map, and you'll end up pasting a picture into this document or into Google Classroom. So we'll kind of go through each step. I want you to make sure that you're following through, but you also need to make sure that if you get lost on a step or not sure how to do it, I want you to think about how to complete something and then kind of fill things in. And because your map has to be of your own. And the main goals of this is to know the difference between distance and displacement, how to draw vectors and add vectors together using the tip to tail method, how to draw X and Y components, but also how to draw displacements. And then once we have a lot of that, we're going to figure out the size of displacement using Pythagorean's theorem. And so those are our main goals. But here we go. This first one, determine your pace. So sorry, you guys, the treasure, it's already been found. And there's a map that we're going to be putting together to how to get it. But this pirate that found it, they kept track of which direction they went in and how many paces they walked. But paces, we don't like paces. Physics pirates, we measure in the metric system. So we have to figure out what that distance is in meters. And that's what the step one is. This pirate, they can walk 10 paces. And when they do that, they're really walking 5.23 meters. To figure out their pace, we need to divide the distance by the number of paces they took. So if they took 10 paces and they went 8.3 meters, their pace would be 8.3 divided by 10, you get 0.8 meters per pace. So this pirate, again, they walked 10 paces and they went 5.23 meters. What would the pirate's pace be? Pause the video and think about that. And all right, if you said their pace was 0.523 meters per pace, you are correct. And awesome. So we figured out the pirate's pace. Now we can figure out the distance that they went in each little step here for how they got to the treasure. We know how many paces that they took going in each direction. So if they took 4 paces, we want to figure out how far that actually is in meters. But we need to use this as a little bit of a conversion of how to get from paces to meters. Well, if they went 1 pace, they would go this far. If they went 2 paces, it's 2 times that. If they went 4 paces, I want you to think, what distance do they actually go? And what am I doing with these 2 numbers in order to figure that out? All right. So if you said that this was 2, you're right. And you are multiplying 4 times 0.523. You're going to do that for all these other numbers. I want you to take a moment. I want you to solve out what the distance is for all these other ones. Yar. All right. Check your answers. So these are the distances that this pirate walked in each case. And really, it's following this path that they used to get from where they started to where the treasure is. Yar. Next thing is that we're going to make our own map. We're going to draw something similar to this, but you have to do it on your own sheet of paper. And you're going to have to add some other details in here. And so I'm going to show that to you right now. And so if you go to this page, step 3 and step 4, you're going to get a blank sheet of paper and you're going to add this stuff. Title, your name, compass that shows north, south, east, west, and you have to show vectors just kind of like that other map did of where that pirate started to how they got to where the treasure was. And you have to mark X where the spot is. It's really we're drawing these things, the directions, how they got from one place to another. And so you don't have to make this perfectly to scale, but your vectors should follow, for the most part, a scale. So if you have one vector that's a little longer than the other one, or twice as long, you should make it look twice as long. And if you have something that's way longer than the other one, you should make it look way longer, or relative to scale. So that's kind of what you're doing. And you can mark where you started, where the treasure is with an X. Yar, you can label it the treasure. Make sure that your name's on it. So if you're me, Robert, that's fine. And this is your physics pirate treasure map. And so here's kind of our treasure map. You need to also add other details. You can add other details like, was this in the school building? Or maybe this is the desert island. You can put trees and other piratey things that are on, like palm trees, other piratey things. You can do a pirate ship. That's fine. But just no blood, no blood. And once you have that, then you need to find out some other information about your pirate treasure map. And that stuff is up here. In step 4, you need to do things like calculate your total distance, draw your displacement on the map, draw X and Y components, calculate the magnitude of your pirate's overall distance, displacement, and then measure the length of your pirates. Well, we'll skip number 5. But you're gonna make it piratey, all that kind of stuff. But these are the main things that you want. Forget about the scale part, don't worry about that. What we really want to figure out is our X and Y components. And so I'm gonna go through each part. One is on your map, you need to also label how far these were. That came from the table that you filled out before. Like we said that this one going north was 2 meters. This one going to the east was 4 meters. I want you to take a moment and fill out the rest of them. Yeah, okay, so mine is not to scale, by the way. And so you want to make yours better to scale than mine, because something that's 4 meters and then something 5 meters and 10 meters, this doesn't look right. And make sure that yours looks a little better than that. Anyway, things that we need to add to this. We need to figure out the total distance. And you're going to also list this on your map. Our total distance, remember that distance is really the path that we followed. It's how far you went. So this pirate, they went from here and they followed this whole path to get to here. I want you to figure out what is that total distance that the pirate went. Go ahead and do that. All right, this one I'm not going to give you. I think you can figure it out on your own. Next thing is we need to draw a displacement. An X component and a Y component. And we're going to solve out for the length of each one of these. But it doesn't necessarily happen all in this order. And you'll see. But when we say displacement, remember displacements are really a line that goes from start to finish. We're going to draw it in, let's just do orange. And so I want you to draw your own displacement. If you were to draw a line that goes from start to finish, how would you draw it? All right, let's check it. So your line should go from start to finish, something like this. But your displacement, it should have an arrow. And this, check it. If you draw it this way, no, that's not displacement. That's going like from finish to start. So your displacement goes from start to finish, and it is this line. We're going to label it as displacement. And now the size of it, we can't really tell the size of it from what we got. We're going to have to do some other things to figure it out. So we need to actually draw an x component and a y component. If you try to remember, which one do you draw first? The x component? You bet. And so drawing your x component, we're going to kind of forget the rest of these things just for a moment, and we're going to just focus on the displacement. Remember x component, y component? X is horizontal and y is vertical. We're going to put those two things together to make a right triangle. So our x component, it runs along the x-axis. But when you draw your x component, remember it stops at the tip or underneath the tip of this arrow. And we're going to label that our x. Next, we draw our y component. Our y component is a vertical line. But if I draw my vertical line like this is not my y component. And this line's going up and to the right. I need a line going up and to the right. And so I need to draw it going this way, and I label it y. So there's that part. Now I need to figure out sizes. And this is where it gets a little tricky. I'm not going to show you everything. But when we talk about sizes, you need to find size for all three of these things: the displacement, the x component, the y component. But think of this. You have this kind of layout, and to figure out the x component, I want you to think you have all these numbers that are here, but only some of them need to be added together to give you the x component. Which parts need to be added together for the x component? You said, oh, just these? Oops. Just these for the x component? Oh yeah, because those added together will be the same size as this one. And for the y component, if you need to figure out the length for the y component, you could, which ones would you add together? And if you said, we add these together, that's awesome. So add them together, and you'll figure out the size of the y component. So you should have the size for the y component in meters. You should have the size for the x component in meters. And now for the displacement. Because the displacement is the longest side of the triangle, now which rule can you use? Oh yeah, a squared plus b squared equals c squared. And make sure you have this on your paper too. And remember your displacement, you are solving for the longest side of the triangle. You could put in the other sides of the triangle to solve for this one. Just make sure at the very end that you take the square root. But ask your teacher if you need other help with this. This is kind of a quick tutorial of it, but you should have all of this stuff done and your pirate map and other details on here. Remember, no blood, but have a good physics pirate day. All right, see you guys.